So what does the Pythagorean converse say? Remember, converse means flipped. We're flipping the two parts of a statement. The Pythagorean theorem worked if we have a right triangle and we need to find missing side lengths. And for the converse, it's if we have or know the three side lengths, and need to know if it is a right triangle. We know that if c squared is equal to a squared plus b squared, then the triangle is a right triangle. And let's draw a little picture to remember what that looks like. Now then we can say if c squared is not equal to a squared plus b squared, then it's not a right triangle. But we can do a little bit better than that. We can say that if c squared is greater than a squared plus b squared, well, then what happens? Let's draw a little picture and see what that means for our triangle. Let's assume that c squared and also c is longer. Well then, our triangle is going to look something like this. And a right angle is no longer a right angle. It now actually happens to be an obtuse angle. Well, then that's the answer. If c squared is greater than a squared plus b squared, and I just saw that there's a square missing, then the triangle is obtuse. Very good. So what is going to happen if c squared is less than a squared plus b squared? And using our picture again, what would happen now if c is actually shorter? Then we would have a triangle that looks like this. And now our formerly right angle is an acute angle, so therefore the triangle is also acute. So then let's look at some examples. Classify the triangle as right, acute, or obtuse. Let's look at number 1. And always remember that our longest side is going to be our C. That always has to be the case. C is always the longest side. Now, do we maybe have a triple here? These numbers look vaguely familiar. Can we divide them by a common factor? All three numbers can be divided by 4, so we get 12 divided by 4 is 3, 16 divided by 4 is 4, 20 divided by 4 is 5, 3, 4, 5 is one of our triples. So then we have a right triangle for sure. See, all without having to do too much math. Okay, let's move on to example number 2. Example number 2 has one of the sides which is an irrational number, so there's not going to be a triple. And now which one is actually our largest side to set up our equation? Square root of 56 looks pretty large. What about the other two numbers? 5 is the square root of 25, 9 is the square root of 81. So that seems to be the longest side. So this is how we're going to set this up now. C squared, and we're not going to put an equal sign or anything here just yet. but we know that we're comparing it to a squared plus b squared. C squared is 9 squared, a squared is 5 squared, and b squared is the square root of 56 squared. So we're talking about 81 is compared to 25 plus, and remember, squaring and square roots cancel each other out, and we get 56. 81, 25 plus 56 is 81. So yes, these two numbers are equal. That means we have a right triangle. All right. In example 3, we have three sides. Two of them actually are irrational numbers. The square root of 4 is of course not an irrational number because it's 2. But nevertheless, we have to do the math. We can't use triples here. The square root of 6 squared, and using our line again as a placeholder for the equal or inequality symbol that we're using later. Square root of 4 squared plus the square root of 5 squared. In other words, and again, as before, squaring and square root cancel each other out. So 6 gets compared to 4 plus 5. 6 compared to 9. 6 is less than 9. So if c squared is smaller than a squared plus b squared, we have an acute triangle. Last but not least, with sides of 2, 7, and 8, 8 squared compared to 2 squared plus 7 squared. 8 squared is 64. 2 squared is 4 plus 49. 64 versus 53. 64 is greater than 53. So in this case, we have an obtuse triangle. For our last example, we need to bring together several things. First, we need to graph the triangle, then find the lengths of the sides, and then use the converse to classify the triangle. Alright, let's get on with it. First, we're going to graph our points, E at 0, 0, F at 2, 4, and G at 6, 2. And here is our triangle EFG. So how can we find those side lengths? And how can we even use the Pythagorean theorem here? But remember, these are in the coordinate plane, and we have done something similar to this before, using the Pythagorean theorem, or actually modifying it slightly so it looks more like the distance formula. We take the square root of both sides. We get c is equal to the square root of a squared plus b squared. So when we want to find the length of our side EF, let's realize that the side EF is the hypotenuse of a right triangle that has these two other sides which go nicely along our grid lines, and we can measure their sides very easily. So EF is the square root of 4 squared plus 2 squared. In other words, the square root of 16 plus 4, which is the square root of 20. Twenty is 4 times 5. So we are talking about 2 times the square root of 5. That's the length of EF. And similarly, FG is part of the right triangle with these two legs. So FG is equal to the square root of yet again 4 squared plus 2 squared. Now we can go through the same math, but we obviously are going to get the same result. That's square root of 16 plus 4 is the square root of 20, which is the square root of 4 times 5, or 2 times the square root of 5 again. And our last side, EG, is part of this right triangle. So EG is the square root of 6 squared plus 2 squared. Square root of 36 plus 4, which is the square root of 40, or the square root of 4 times 10, which is 2 times the square root of 10. EG is our longest side, 2 times the square root of 10. So that's going to be our c squared. Let's set up our equation, or see if it even is an equation. C squared compared to a squared plus b squared. Now, for doing this now, rather than taking the fully simplified form, it might actually be easier to just take these numbers here. So we're talking about the square root of 40 squared and square root of 20 squared plus another square root of 20 squared, because as we know, squaring and square roots cancel each other out. So we are saying 40, and here we got 20 plus 20, which is 40. So 40 is indeed equal to 40, and that allows us to say that the triangle that we graphed is actually a right triangle. Phew! That was a lot of work. Good job though, you guys, and we have done everything. We found our answer using the different concepts that we have learned in this lesson. So for your summary, what I would like you to do is spend a few moments and write what is the difference between using the Pythagorean theorem and the converse. And when you think about the difference, I want you to think about it this way. What do you want to find when you use the Pythagorean theorem, and what do you want to find when you use the Pythagorean converse? Alright, so much for this, and I will see you in class.